the biology and physics of neural tissue. I'll give two examples here of researchers who have concentrated on the special qualities of neural tissue in relation to the problem of consciousness. The first is the work of Crick and Koch on 40 Hz oscillations. As Andy Clark explains, the focus of the work is on the neural mechanisms that achieve binding, where binding involves establishing a certain relation between neural populations carrying different types and items of information, e.g., binding MT motion detectors to V4 hue detectors as part of the process, representing a certain face in the act of speaking. End quote. Such binding, Crick and Koch claim, is achieved by frequency-locked oscillations in the various neural populations, with the locking perhaps mediated by circuitry linking the cortex to the highly connected thalamus, the so-called thalamocortical loop. Spike synchronizations in the 40 Hz range, actually anywhere between 35 and 70 Hz, are then depicted as joining the various neural representations into a coherent whole, which is then placed in working memory, which in turn renders the coherent percept poised for the widespread control of action and report. Jeffrey Gray notes that this concept of the neural correlates of consciousness, specifically for vision, is incompatible with the notion of a single Cartesian theater for all conscious experience. Crick's approach implies, in contrast, that there will be multiple foci of neural activity, each proximal to a different type of qualia. However, it further implies, unlike Dennett's multiple drafts model, that only some forms of neural activity can serve as neural correlates of consciousness. In particular, neural correlates of consciousness should be found in perceptual systems, since one is consciously aware of percepts, but not in systems whose operation does not figure in conscious awareness. Ones, for example, that control pupillary dilation or walking. My second example of a neural tissue focus is the work of Penrose and Hamerhoff, who are concerned with the possible quantum processes taking place in neural tissue. Penrose and Hamerhoff are thoroughgoing in their panpsychism. As Stuart Hamerhoff says, we address the hard problem through a philosophical approach known as pan-experientialism, dating to Whitehead, who saw consciousness as occasions of experience in a wider basic field of proto-conscious experience. In our view, the wider field is fundamental space-time geometry, the fabric of the universe, which is everywhere at the Planck scale. Consciousness is a series of events, quantum state reductions in quantum space-time. And Gray explains that the quantum state reductions of this quote are the fundamental tool in the theory. As well as the hard problem of consciousness, Penrose and Hamerhoff address two major outstanding problems in fundamental physics: the manner in which the strange microscopic world of quantum mechanics collapses to give rise to the macroscopic world of everyday life, and the unification of quantum mechanics and quantum gravity. The theory is nothing if not ambitious. It proposes an interlinked solution to all three of these problems. Unit 7 of this course will be devoted entirely to quantum theories of consciousness.